All right, Module 10, Chapter 3, Part 2. Reflection AC voltage from a short circuit. Reflection is complete with the radio frequency line terminated with the short circuit, but effectively on the voltage. Current difference for the effect of the obtained with the open end line with the voltage reflect the opposite phase. Will the current reflect with the phase again? Look at the series diagram figure 327 of the left hand column represent with the current in the right hand column show with the voltage change with the shorted line. A standard representation shining wave at the shorted line is shown in figure 330 with the voltage in the solid line, current with the dashed line with the voltage 0 at the end of the center of the 1/2 wavelength, maximum 1/4 length, and 3/4 length with the current is maximum at the end of the center of the minimum 1/4 length, 3/4 length of the line. Generator short circuit show the maximum output voltage 1/4 length, 3/1/2 length, 3/4 of the length. As we discovered, the voltage current wave of the transmission line with a point out several differences between the open short of the line with the but basic difference to apply with the standing wave patterns of the open and the shorted lines. You get the difference comparing the figure 329 view E with the figure 330 with the note of the current of the voltage standing the wave. They're shifted 90 degrees with respect to the termination at the open end of the line. Voltage is maximum 0. There is no loss in the line. The short circuit is the current maximum voltage is the minimum. Terminating a transmission line. The transmission line either is non-resident or resident. First letter, let's define what the term of the non-resident line with the resident line. The non-resident line have no standing wave of the currents and voltages. A resident line the standing waves have the current waves of current and voltage. Non-resident lines are either infinitely long and terminate with the characteristic impedance, infinite of the reflection of all energy traveling down the line that absorb the low of the terminates of the line, the infinite standing wave that are present. Type of the line sometimes what was spoken is the flat line in addition with the pickup of the load of the impedance of the shift of the lines equal to the characteristic of the impedance, and no special tuning devices are required to effect the maximum power transfer, hence the line is called the untuned line. The resonant lines. Resonant lines are finite length with not terminated with the character of the impedance. Therefore, the reflection of the energy due to occur with a lot of the load of impedance difference for the character of the impedance of the line. Therefore, the input of the impedance may not be perfectly purely resistive, but may have the reactive component. The turning device are used to eliminate the reaction of the ring about maximum power transfer from the source of the line. Therefore, the resonant line is sometimes called the tuning line. The line also may be used for the resonant or tuned circuit. Resonant lines are sometimes said to be resonant with the applied frequency. This means that one frequency line with the resonant circuit acts as a resonant circuit. In the active, and it may either have high resistive circuits, parallel resonant, or low resonant circuit, serial resonant. The line may be made to act with the manner of the either open short circuit in the output of the cutting into some multiple quarter wavelength. At the point of voltage maxima and minima, the short circuit of the open circuited line, the line impedance is resistive. One short circuited line at each of the point with the odd number of the quarter wavelength for the receiving end of the high impedance, figure 331 view A. If the frequency of the applied voltage line is varied with the impedance increase with the effective length of the line, change of this variation is exactly the same as the change of the impedance of the parallel resonant circuit when the applied frequency is varied. Alright, so for the highs, lows, eve, quarter length, half length, your sending impedance, various length of the termination, short circuit, open circuit, quarter length, voltage, amps, voltage, open, even quarter length wavelength of the points for the short circuit with the impedance is extremely low, with the frequency of the voltage applied with the line with the varied impedance with this one with the creep of the adjust with the impedance with the resonant circuit varied with the frequency applied to it. The same is true with the open end line. Figure 331 view B, with except for the points for the high and low impedance are reversed. At this point, let us review some of the character of the resonant circuits, so we can see how the resonance lines, the sections may be even the inductive capacitive circuits. Parallel resonant circuits are the following characters of the resonant impedance occur with very high resistancy. A low frequency circuit has infinite impedance. The open circuit with the other resonant impedances decrease rapidly, and if the circuit is resonant above at a point above the generator frequency, the generator frequency is too low. More current flow for the coil through the capacitor. This happens with the inductive capacity. And decrease the frequency of the capacitive and reactancy increases. Series resistance has three characteristics. Resonance impedance that are very low resistance. Loss free with the circuit with the zero with the impedance, the short circuit with the other resonance with the impedance with the decrease rapidly. If the point above the generated frequency is too low, the capacitive reactance is large, the inductive reactance is larger than the inductive reactance. The circuit acts as capacitively. If the circuit is resonant in a point below the generator frequency, if the generator frequency is too high, the inductive reactance is larger than the capacitive reactance if the circuit is inductive. So the impedance of the generator C, the quarter wavelength at the point with the shorted is that the parallel resistance circuit with the shorted quarter wavelength over the line may be U with the parallel resistance circuit figure 331.
We have to go and see about another pair of glasses for him and get his jewelry, and we'll be back later.
Hi. Figure 331 view C. An open quarter length of the line may be U with the series resistance circuit with the mirror over the resonant line that is greater than the obtained lumps capacitance and inductance. Impedance and various length over the open line. With the figure 332 with the impedance with the generator C with the various length of the line is shown at the top of the curve above the letters of various height that show the relative the value of the impedance represented. But I'm presented with a generator from the various weight line length. The circuit symbol indicates the equivalent electrical circuits for with the transmission line, each of a particular length with the same wave the voltage current that is shown to each of the length of the line. Okay, voltage current impedance on an open line circuit. This is your short circuit and inductor capacitor, low resistance, high resistance. High resistance on your short circuit and low resistance on your at all odd quarter wavelengths, 1/4, 3/4, etc. The voltage minimum, the current is maximum, the impedance of the minimum, at all quarter wave points for the open end of the transmission acts as a series resonant circuit. The impedance of the equivalent very low is resonant with the brain, but the being zero by a small circuit law. At all quarter wave points, 1/2, 1 and 3 halves, etc., where the voltage is maximum, the current is minimum, the impedance is maximum, the comparison with the line with the inductive capacity of a resonant circuit will show that an even number of the quarter wavelengths and open line acts of the parallel resonant circuit of the impedance is therefore extremely high resistance. In addition, with resonant open lines may also act as nearly pure capacitive inductance. The illustration shows the open line with a quarter wavelength long as the capacity also acts as inductance with a 1/4 wavelength, the capacity with a 1/2, 3/4 wavelength, as an inductance 3/4 wave, 1 wavelength. The number of the open transmission line with the equivalent circuit is shown by the illustration. Alright, impedance of various length of a short line. Figure 333 shows the which starting with the odd quarter wavelength of the voltage has high current level wavelength of the impedance for the higher since the condition is very similar found within the parallel resistance circuit of the shorter transmission lines acts as parallel resistant circuits at lengths. Show the impedance is equal to the passive reactance, and then we get various current impedance on a shorter line.
Me and your mom going by in case you want to go somewhere and keep in the truck.
Alright. I got it. At quarter wavelength, wave points, voltage minimum of the current maximum impedance of the minimum since the quarters are similar with the index of the capacity of the circuit of the shorter transmission line, whose lengths are even the number of the quarter wavelengths out of the series of the resonant circuit. The resonant shorter line of the lines, open line, but they also may have is pure capacitance and inductance. The illustration shown with the shorter line less than a quarter length wavelength, long as the inductance shorter line with the length of 1/2, the 1/4 to 1/2 length is capacitance from 1/2 to 3/4 wavelength. Line acts as an inductance from 3/4 length to one wavelength. It acts as capacitance and so on. The equivalent circuit is shorter line with various length is shown in the illustration. Properly chosen line segments may also be used as parallel resistant series resistant inductive capacitive circuits. Alright, standing wave on a transmission line. The large variety of the termination with the rare frequency, each of the type of the termination character of each of the standing waves on the line, the nature of the standing waves determine the type of the termination due to the waves. Termination with the character of the impedance. Termination with the character of the impedance will call the constant reading of the AC meter one to move along with the length of the line, illustrated in Figure 334. A of the curve of the provided there are no losses in the line will be short line and will be a straight line. If there is loss in the line, amplitude of the voltage and current will diminish as they don't move down the line. The losses are due to the DC resistance to the itself. No losses, with losses, open and one wavelength to shorted, and inductive capacitance equal to the impedance. Inductive reactance equal to impedance, and resistance is greater than the impedance. Resistors less than impedance. Termination of an open circuit. These is an open circuit with the radio frequency over the figure 344 voltage. You see the voltage over the maximum end of the current with the minimum of the distance for the two adjacent zero current points at 1/2 wavelength. The distance between the alternating zero current points and the one wavelength. The voltage is 0 to distance of 1/4 length at the end of the line. This is true with the frequency of voltage peaks occur at the end of the line at 1/2 wavelength from the end of the end at each half wavelength thereafter. Termination in a short circuit. One line terminated the short circuit shown figure 334 view D with the voltage 0 at the end of the maximum 1/4 from the end of the current is maximum end of the 0 1/4 from the end and the alternating maximum 0 1/4 thereafter. Termination and capacitancy. When a line is terminated with the capacitancy, but the capacitor does not absorb the energy, returns all of the energy to the circuit. This means that 100% of the reflection with the current of the voltage reflects or the voltage relationship that are somewhat involved with the previous type of the termination. For this explanation, assume that the capacitive reactance equal to 0 and character of the intensity of the line. Current and voltage in favor of the arrival at the end of the line with the following of the capacitor character for the impedance connected in the receiver with the shifting of the phase relationship with the current voltage arriving in phase, leaving out the phase. This results in the standing wave configuration shown in figure 334 view. Even the standing wave of the voltage is a minimum. The distance is equal exactly 1/8 of a wavelength from end. The capacitive reactance for the character for the impedance of the smaller capacity of the termination looks more like an open circuit. The voltage minimum moved away from the end of the capacity reactance. Smaller the character for the impedance minimum moves toward the end. Termination with the inductancy. When the line terminated with the inductance, both of the current and voltage shift in phase at the arrival at the end of the line, but the inductive capacity is equal to the character of the impedance and resulting in standing waves are shown figure 334 view F. The current minimum to the 1/8 of a wavelength from the end of the line. The inductive reactions increase the standing waves appear at the crop at the end of the when the inductive reactance is decreased, standing waves moves away from the end of the line. Termination of the resistance not equal to the character of the impedance. Whenever the termination is not equal to the character of the impedance, reflections occur on the line. For example, if the termination eliminates element contains resistance absorbs some of the energy, but the resistive element does not equal the character of the impedance, some of the energy is reflected. The amount of voltage reflected may be found by using the equation. Voltage reflected is equal to voltage incident. The incident voltage over the resistor inductancy minus the character of the impedance over the resistor inductancy plus the comparative of the impedance. To try to define the resistor inductancy of the preceding equation, you will find the reflected voltage equal to the incident voltage of the resistor inductancy equal to 0 with the infinite large. When the inductance results in resistor inductancy is equal to the character of the impedance, no reflected voltage occurs. When the inductive reactance and the resistant inductancy is greater than the capacitive inductancy, the voltage of the resistor is positive but less than the incident voltage. As for the result resistor inductancy, the increase and the approach of the infinite value of the voltage and the reflected voltage increase the across the incident of the voltage value. The resistor inductancy is smaller than the character of the impedance. And reflected voltage has the negative value of the mean for the reflected voltage of the opposite polarity of the incident wave at the termination of the line. Inductive, the resistor inductancy equal to 0 with the voltage reflected voltage over the incident voltage and value. The smaller the value of the incident reactant or the voltage reflected, and thus the smaller the peak amplitude, the standing wave, the higher the minimum value. All right, terminations and resistance greater than the character for the impedance. The inductive reaction, the resistor inductancy is greater than the character for the impedance. The end of the line is somewhat open circuit with the standing of the wave that appear on the line with the voltage maximum appear at the end of the line. Also about halfway with the intervals back over the end. The current is minimum not 0 at the end of the line, maximum of the old wave quarter wave. Since the power of the incident wave of the consumer the load resists the minimum value of the current or less than the standing wave of the open-ended line. Figure 334 view G illustrated the standing wave of the condition. Termination and resistance are less than character of the impedance. The resistor inductance is less than the character of the impedance. The termination appears at the short circuit of the standing wave as shown with the figure 334 view A. Known for the line terminates the current loop peak voltage node minimum. The value of the maximum minimum voltage current approach with the shorted line of the inductance reacts. The resistor inductance approaches 0. A line does not have any particular length to produce the standing waves. However, there cannot be an infinite line with the voltage current must be reflected with the producing standing waves. For the reflection curve of the line must be not terminated, and its character for the impedance reflection occurs on the lines terminated with the open short with capacitance and inductance because if no energy is absorbed by the load. If the line is terminated with the resistance not equal to the character of the impedance of the line, some of the energy will be absorbed, the rest will be reflected. The voltage and current relationship of the open and shorted lines opposite of each other, shown in Figure 334 of UC and D, with the points of the maximum minimum voltage current that determine the output end of the line, because the reflection always begins at the end of the line. Begins at the end, sorry. Standing wave generation ratio. The maximum standing wave of the transmission line yield the information of the equipment operating condition, maximum power absorbed with the load of the impedance inductance is equal to the impedance load maximum power is equal by the load of the impedance load is equal to the character of the impedance. If the line has no standing wave, the determination of the line is correct, the maximum power transfer takes place. You probably notice the variation standing wave show over the near of the radio frequency line with it being terminated with the character for the impedance. The variation along with the voltage along the line means termination of the far of the character for the impedance. Small variation means the termination of the character for the impedance. Therefore, the ratio maximum as the minimum is a measure of perfection termination of the point of the line. The ratio is called the standing wave ratio, or SWR. Is also expressed in whole number. For example, the ratio 1:1 describes the line terminated and the character for the impedance voltage standing wave ratio. The ratio of maximum voltage, minimum voltage, maximum to the minimum voltage of the line is called the voltage standing wave ratio. The voltage standing wave ratio is equal to the voltage max over the voltage minimum. Vertical lines formula indicate the enclosed quantity that are absolute with the two values that were taken without regard polarity, depending on the nature of the standing wave. The numerical value of the voltage standing wave ratio ranges from values of 1, the inductance, the impedance, and impedance load equal to the character of the impedance, no standing waves, to infinite value with the theoretical complete reflection, since there is always some loss along the line. The minimum voltage is never zero, and there is always a voltage standing wave ratio. There's always some infinite value. However, the voltage standing wave ratio is to be useful quantity. The power loss along the line must be small in comparison to the transmitted power. Your power standing wave ratio. The square voltage standing in the wave ratio is called the power standing wave ratio. Therefore, power standing wave ratio is equal to the power max over the power minimum. The ratio has become the instrument is used to detect standing wave. The reacts to the square of the voltage. The power is proportional with the square of the voltage. The ratio of the square of the maximum and minimum voltages are compared to the power standing wave ratio. In this sense, the name is misleading because the power along the transmission line does not vary. Your current standing wave ratio. The ratio to the minimum current along the transmission line is called the current standing ratio, or ISWR. Current standing wave ratio is equal to the amps max over the amps minimum. The ratio is same if for that of the voltage can be where the measure for the mullet made with the loops in the same magnetic field along the line. You get the same result as the voltage standing wave ratio measurements. All right, Chapter 3 summary.